Welcome back to Smart Tech and Biz, the channel where we break down the technology shaping tomorrow's economy with clarity, precision, and zero hype. Today, we're looking at a move that could reshape global energy storage. CATL, the world's most influential battery manufacturer, has just launched the largest, most advanced energy storage validation center on Earth. And at the same time, they've confirmed that sodium-ion batteries enter mass production this year. This isn't just a milestone, it's a strategic shift in how the world will test, trust, and deploy energy storage at scale. Let's break it down. Energy storage is no longer a nice-to-have. It's becoming critical infrastructure as essential as power plants, transmission lines, and substations. But here's the uncomfortable truth. 1 in 5 large energy storage stations worldwide are underperforming. Nearly 50% face grid connection delays of more than 2 months. This gap between what's installed and what actually works is slowing down the global transition to renewables. CATL's answer is bold: a facility that tests entire energy storage stations, not just individual components under real-world conditions, before deployment. This is the first time the industry has seen validation at this level. CATL's new Xiamen Energy Storage Validation Research Institute, or ESVL, covers 10 hectares and cost RMB 3 billion, around $620 million AUD. But the real story is what's inside. 5 world-leading laboratories designed for full system testing. 1. Station-level grid integration lab. The world's first lab capable of testing an entire energy storage station. 35 kV, 100 MVA grid simulator. Real-time simulator 14x, larger than the one at America's NREL. Sets a new global benchmark for grid-level testing. This is like crash testing a whole car instead of just checking the airbags. 1. High Voltage Safety Lab. Stress test systems under extreme electrical conditions. 1. Thermal Safety and Combustion Lab. World's first indoor combustion facility with a 20 mm calorimeter. Measures heat release during failures, fires, or thermal runaway. This is where they push batteries to their absolute limits. 1. Environmental Reliability Lab. Simulates the harshest environments on Earth. 50 degrees to 100 degrees, salt spray, rain, sandstorms, high altitude pressure up to 7,200 meters. 1. Electromagnetic Compatibility Lab. Ensures systems don't interfere with grid electronics or communications. Together, these labs move the industry from component testing to station-level validation, a leap forward in reliability and transparency.
The industry is entering the gigawatt era where energy storage stations rival power plants in scale and importance.
That demands scientific rigor, transparent data, reliable performance metrics, bankable, insurable systems. This testbed gives regulators, insurers, and investors independent, traceable, real-world data, something the industry has never had at this scale. Energy storage becomes a trusted asset class, not a gamble. Alongside the testbed launch, CATL confirmed that sodium-ion batteries enter mass production this year. This is a major shift. Why sodium-ion matters? Uses no lithium, cobalt, or nickel. 30% cheaper than LFP. Retains 90% capacity at 40 degrees CC. Ideal for grid storage, micro EVs, and cold climate applications. CATL solved the key bottlenecks: moisture control, hard carbon gas generation, aluminium foil bonding, mass production of self-generating anodes. This isn't a prototype. This is a commercial product ready for deployment. With sodium-ion moving into mass production, CATL can now shift long-term R&D toward lithium-air batteries. Lithium-air is the holy grail of battery chemistry. Theoretical energy density far beyond today's lithium-ion. Potential applications in aviation, long-range EVs, and grid storage. But it comes with challenges: safety, stability, oxygen management, cycle life. CATL's new testbed gives them the perfect environment to test these next-generation systems safely and at scale. This announcement signals 3 major shifts. 1. Energy storage becomes more reliable. Full system validation reduces failures. delays, and uncertainty. 1. Sodium-ion becomes a mainstream technology. Cheaper, safer, and better in cold climates, ideal for large-scale storage. 1. The race for ultra-high-density batteries accelerates. Lithium-Air could redefine what's possible in electric mobility and grid storage. CATL isn't just building batteries. They're building the global standard for how energy storage should be tested, validated, and trusted. This is a pivotal moment for global energy storage, a new testbed, a new battery chemistry entering mass production, and a new frontier in lithium-air research. If you want a deep dive into sodium-ion versus lithium-ion or a breakdown of lithium-air technology, drop it in the comments and we'll build it next. This is Smart Tech and Biz. Stay sharp, stay curious, and I'll see you in the next one.